See that no movement, LED is off. See, it has detected the movement of my hand and then LED remains on for 2 seconds. See that no movement. I move my hand, it has detected the movement of my hand. It's off, no movement. See, again it has detected the movement. So that's how it's gonna work. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface a PIC16F877A microcontroller with a microwave radar sensor module. It's just like an alternate to a motion sensor. It's more like you can see it can detect any object within a 360 radius up to 5 to 7 meter of range. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and this is the microwave radar sensor. As you can see, it has like 1 2 3 4 5 and 6 pins, sorry, 5 pins, 1 2 3 4 and 5 pins, and they are labeled as well. So let me label them again for you. So the top one, if you hold it like this, is a CDS, then we have V in, then we have out, then we have ground, and then we have 3.3 volt pins. So the only 3 pins you are going to need it to connect it with a PIC are V in, out and ground pin. So let me show you how to connect it with a PIC. You connect the ground pin with the ground of the PIC like this, V in pin with the VCC pin of the PIC like this. You can give up to 8 volt here, but 5 volt is ideal enough. And then guys, the higher the voltage you give, the more the power and range this module will have. Now guys, for the center pin, that is the output pin, you can use any available digital input output pin. Whenever an object is detected, this sensor will send a 1, else it will be 0. So you can connect it to any GPIO pin. I am going to use the pin number C2, that is pin number 17 of the PIC. In this way guys, our microwave radar module is connected with a PIC. Let me now connect an LED. This LED will turn on whenever an object is detected. We will program the PIC in such a way. So as you know, LED has only 2 pins, one is longer and one is shorter. The shorter pin is always the ground and longer pin is always the power pin. Now guys, for the shorter pin, you connect it directly with the ground of the PIC like this. For the longer pin, you will need a resistor, a safety resistor. 220 ohm is good enough. You can use the different values, but the higher the value, the dimmer the LED will go. So 220 ohm is ideal. Now guys, let's connect it. And now for the LED pin, you need to connect the longer pin, that is the 5 volt pin, to the one end of the 220 ohm resistor like this. From the other end of this 220 ohm resistor, you can connect it to any available digital input output pin of your PIC. I am going to use the pin number D1 like this. That is pin number 20. So guys, in this way, our microwave radar is connected and our LED is connected with the PIC. Now we are going to program it in such a way that whenever an object like my hand comes in front of in the range of this radar, then this LED will turn on. It means that an object is detected within the range. So that will be simple as that. So before we get to micro C for programming, let me introduce you to the hardware. So guys, this is our hardware over here. You can see that it's simple as that. This is our microwave radar sensor. As you can see, it is the same as shown in the presentation. And guys, it is connected in the same way as well, only 3 wire. Now this is the LED, this one over here, which I will use, and this is our PIC16F877A microcontroller in the back. So this is simple as that. This is our total setup, and this is my hand, and it will be used as an object. So let's get to our micro C for PIC programming. So this is our micro C for PIC. Let me zoom it in. So guys, as you can see, I'm going to use the version 7.2.0. Higher versions are also available. Always use the latest version. Latest is always better. So for now, click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project, Microwave Radar Tutorial Real by Learning Microcontrollers. So this is the name of the project I just wrote. This is the path where it will be stored. Select the microcontroller you are going to use. I'm going to use a PIC16F877A, and select the crystal you are going to use. I'm going to use a 20 megahertz crystal. This is the crystal connected to the pin number 13 and 14 of the PIC. So I have a 20 megahertz crystal there. Click on Next and finish. So guys, this window pops up. Before you do anything, first of all press Ctrl S to save your work like this. Now guys, first of all, we have only two things in this project as shown in the presentation. One is simply our output pin that is going to the pin number C2, and then we have LED at D1. So we initialize both of these pins. So first of all, we initialize the sensor at pin number C.F2. So I write this C.F2 equals to 1. Now in case of Arduino, you use the command called pin mode output or input. In case of a PIC, you use the trace register. 1 means it's an output, input, and 0 means it's an output. So since it's a sensor, so it pin must be declared as an input because we will receive the value from the sensor. Then give it the initial state. Initially, the pin must be at 0 because as told you earlier and as mentioned in the datasheet of the sensor, whenever an object is detected, it will send a 1. So initially, our pin must be at 0. Now give some initialization delay. This is not necessary, but I suggest you always give it in the one-time loop. Now guys, this is our sensor pin initialized. Now we initialize the LED. So LED is at D1. So write down trace D.F1 equals to 0. Now see the difference here. Just like in case of Arduino, it is like pin mode output. So in case of micro C for PIC, it's trace register, then the pin name, and then 0 means it's an output and 1 means it's an input. So sensor pin was input, so we use 1 here. Now we have an LED, and LED is an output. Output requires the pin to be an output, so there it's an output. Now give the initial state. Port D.F2 equals to 0. Initially the LED must be off. So just like in Arduino, you use a command called digital write high or low. Here you use this command, and 0 means it's low and 1 means it's high. Now give some initialization delay. It's not necessary, but I suggest you always give it in the one-time loop. Now guys, we move on to our forever loop. Write down while 1. Forever loop starts here and ends here. Make it look beautiful like this. Now guys, first of all, we will need to do some checking here, that if then an object is detected. So write down if port C.F2 double equals to 1, that an object is detected, then now here we will send the sensitivity, that what sensitivity you want. If you want the higher speed, then leave it blank. If you want to set a sensitivity that an object should only be considered detected, it is detected for some span of time. So I make it like delay. Now if an object is detected, an object is still detected for more than 10 milliseconds. Now object is detected and 10 milliseconds has passed and still the object is there. Then it will turn on the LED at pin number D2 like this. If you want the full speed, you don't want this delay here, like it might be because of some accident an object is detected or something which you don't want to detect. Then you can increase this delay to increase the, you can say the, this will change the sensitivity of the sensor. Lower the value, higher will be the sensitivity, higher the value, lower will be the sensitivity. So 10 is enough for me. So the LED will turn on. Now close the brackets. Else, in case nothing is detected, then LED will remain off. So the initial state of the LED is off. It will go back to the initial state like this. So guys, our it's D.F1 not F2. So LED is at D.F1. Sorry, make it correct here, because it was to give an error anyhow when we build the code. So we build the code, it successfully built. See what is happening here. We just initialize our sensor pin as input, then the LED pin as output. LED is at D.F1. Then we check for the object to be detected by the sensor. If the object is detected, a 1 will be sent. An object is detected, but now we are checking that if the object is detected for more than 10 milliseconds, then it checks again that if still the object is there, then it will enter into the loop and will turn on the LED. Then the LED will remain on if the object is still there, but in case the object is not detected, then LED will turn off. That's all. Now guys, we build this code and write it using the PIC16 programmer tool. This is the PIC16 programmer tool. Click on file, import microwave radar tutorial. This is the hex file we just made. Click on write. The new code is being written. Let it write. Let me zoom out and we move on to the hardware as soon as it writes up. So guys, as you can see, it is written. Let me power it up using the PIC16 programmer tool. Okay, let's move on here. So you can see that the LED is on. It means an object is detected. Now the LED is off. no movement. Now I move the hand, see, it has detected the movement. It remains on for 2 seconds. That is the time in the sensor. Now again, see, it has detected the movement of my hand. Now it's off, no movement. I'm trying to control my breath, so it should not be able to detect any movement. Now I will move my hand. See, it has detected the movement. It has a range of like more than 7 meters with a maximum power, maximum voltage that you can give to the V-in pin. Now again, no movement, nothing is detected. I move my hand, see, it's detected. So whenever it's detect an object, by default the sensor gives 1 for 2 seconds. Like for 2 seconds the LED will remain on. This is the value of this sensor. See, no movement, it's off. Now I move my hand, it's on. So guys, this is it. This is as simple as that. I hope you guys learned something from this video. If you have any questions, you can ask in the comment section below, and I will share all the micro C4 PIC files, including this code file, hex file, C file, into the Google Drive link, which will be whose link will be in the description of this video. You can simply open that link. That will be a link to my Google Drive, and download all these files from there. So guys, thank you very much for your time. I hope you guys learned something, and we'll meet you in the next videos. Goodbye.